Hello everybody, my name is Alexandra. I'm a mobile developer. Anyone here doing iOS or maybe Android apps?
I have, but not doing it right now.
Okay, couple of people. And the rest of you still developers, backend, frontend, so on? Okay, so just between us, developers, can we agree that it's very, very hard to take on a new project? Because you don't know anything about the problem domain, you know even less about the solution, and you could try looking at unit tests to figure out the problem, the solution, sorry, and they're just very, very deep into code, and you probably won't understand anything just at the beginning. So what I'm proposing today is maybe a solution to make your life easier and in the process get some more test coverage. You've maybe heard yesterday and this morning about behavior-driven development, so I'm going to skip through this part very, very fast so we can get to the cool stuff. Behavior-driven development is an outside-in development philosophy in which the application code is written only after its externalities have been defined. Its purpose is to be a collaboration tool where you can sit down with your customer and work together. You're basically having conversations with them, and in the process you tend to uncover all kinds of gaps, misunderstandings, and so on between your perspective and your user's desired result. In order to get to a common ground with them, you need to be discussing examples and writing them down in a language that everyone can understand. This is not only useful for, let's say, non-technical persons, but it's useful for future members who can understand the project just by reading your BTD scenarios, and it's also a favor you are doing your future self because chances are in 6 months to a year you won't remember that specific implementation detail. At the end of this process, you get documented features that are tied in with your development environment, with your testing process, and you have concrete, executable, easy-to-repeat behavior that lives in your automated tests, which is great for continuous delivery. Behavior-driven development moves the focus on higher-level purposes, such as what does the user want, how do they get there, and unit testing still happens, but only later in the process. So if you want to give this a try, keep in mind that you need to find out what the user wants. So it's very, very important to involve them to make sure that you're building something that they will actually use. And speaking of involvement, everyone in the team should contribute to defining the specs. For example, as a mobile developer, you have to know a bit about the backend, you have to know what Apple recommends as their design guidelines, so you can bring this knowledge to the meeting, and you can also find out what the business owner wants you to build, why, and so on. Now, as developers, I know that I myself focus first on how to build a thing. I think in terms of API, of architecture, and so on. But in behavior-driven development, the key is to keep it implementation free. So you need to think about behavior. You need to think about specifications, and for your tests, you need to illustrate the business rules with examples. Functional specifications are something that describe the system. They're written from the user's point of view in a step-by-step form. And to give an example, if you know the structure given when then, this is what I'm talking about. And for developers, they serve as an entry point to the classic TDD style. What happens is that you write a failing acceptance test, you write a failing unit test to implement that. You write just enough production code to make the unit test pass, and then you write more unit tests until your acceptance criteria is met. And since I introduced this concept, acceptance tests are executable specifications written in a domain-specific language and describe how the user will interact with the application. In other words, it involves testing, writing tests to mirror your user's behavior, which has been agreed upon by your software customer during the development. Now, if your tests pass, it means that your software is feature complete, and it means that your software meets the requirement. The thing is, though, it involves that you run your tests on the full system, so you need to have your requirements nailed down before you start coding. The good part of this approach is that it finds bugs that unit tests can't. The tests are described in plain English, and you can have a method of saying, this is how much of my software I have built, this is how much I still have to build. Now, the bad part is that once you are moving up on the testing pyramid, your tests tend to touch more code, and failure can be hard to diagnose. But the trick is to not test business logic pieces through the UI. Think instead of testing flows. Think of making examples of how your app will actually work, and try to test those things. One thing I should mention, you can do acceptance testing without the UI, and you can do UI tests without making them acceptance tests, but right now I want to focus on both of them, so making a combination out of them. Right, so in order to do UI acceptance testing, keep in mind that you need to verify what the user can see. And if you can make out just a couple examples of how the code you wrote is useful to the user, you can make that into an acceptance scenario. I know some people don't like unit tests, and that's because they come from a bit of a different environment. In the mobile market, which is oversaturated with products, you need to offer a great functionality, but you need to also offer a great user experience. So from this perspective, UI and requirements go hand in hand, and when there's a change in one, there should be a change in the other to reflect that. Another thing that is quite specific to the mobile market is the device fragmentation. And I'm not just talking about Android screen sizes, but I'm talking about supporting two different UI metaphors, one for iOS and one for Android, and maybe one for Windows Phone if you want. Now, another thing I should mention is that you don't write UI tests in favor of unit tests or the other way around, so they both serve a purpose. You should have both. And the difference with UI tests is that they run on your simulator or on your emulator, or even better on a real device, on an environment that is very, very close to production. And most of the time they don't care about system internals, they don't care about how you implement a certain feature, they just want to know if it works, not how it's done. You are best served if you make UI tests during the development of the app, and you can use those as regression tests. You can have them tied in your continuous delivery system, and so on. If you already have built an app, you might not get something out of writing UI tests after the fact, but if you are still fixing bugs, you could write the UI test to demonstrate the bug. You can make a fix for it and then make another UI test to prove your result. That's about it, and I'm going to talk about the tools now. If you're familiar with Calabash, it's a framework written in Ruby. It allows you to do UI interactions. You can press buttons, enter text, make swipe gestures, and all kinds of validations. But since I don't work with Ruby, I work with Xamarin UI Test, which is based on Calabash. But I write my tests in C# and I get the NUnit runner, which should be familiar to you if you're a .NET developer. And I think I'm going to go into the demo now. Seems to be a bit complicated. So I already have an app that I built, and for this app we're going to create some UI tests. If you know TransferWise or Azimo, this is kind of it, and don't judge the name because I was under pressure. I want to send money from my local currency to a friend's local currency, and what I do, let's say I live somewhere where euro is used. I want to send money to my friend in the UK, and I have here I don't know how this will work. Let's say I have here a number. I'm very sorry, I have a confirm button, but the screen is very the emulator is very big.
It's 800, I think.
You can scale that if you want.
This is the maximum. No, I can only make it bigger like this. Oh well, I can. You see. All right, and then I should see a message that my transfer has been done. So this is the app, and now I'm going to show you the test project. So this is my solution. It has the same name as my app, and I have here a project with unit tests. This is Xamarin Studio, by the way. It's very similar to Visual Studio, and through NuGet I got two packages. I got NUnit, which is the test framework, and Xamarin UI Test, which will perform the app interactions. I've got two more libraries from SpecFlow, but we will talk about those later. I have a folder with my binaries. Yeah, this is there. So why do I do this? Because I need to have my app built before I run unit tests on it. And for example, if I was using something other than Xamarin, if I was using Java, I could write my app in Java, make an APK file of that, and just put it inside this project, and it would still work. I have one configuration file. This is called app initializer. Inside there's a single method. It takes a single argument, and this is the platform. It can be iOS or Android. It's very simple. And based on that argument here, I return an APK file if my tests run on Android, and then I return an app bundle if my tests run on an iOS device. If I go inside the tests, you can see here the NUnit structure. You might be familiar with it if you do C# or .NET. I have my text fixture here. The only difference is that it takes in this argument, which says my tests will run first on Android and then on iOS. I have, as I said, this platform here. I have an instance of my app, and in my setup method, this is the one that runs on before every test. I new up my app because I don't want state from a previous test to affect my current test. So every time I make a new test, I open up the simulator, perform my validations, and then close it back down. Alright, here I have a single test, and I try to run it. I'm going to show you just iOS today because it's faster. And I will say run test. Does anyone know what REPL stands for? Okay.
Read, able, print.
Yes, that's exactly it. So once my app launches, here, I'm going to get a console window, and there I can interact dynamically with my UI. Alright, this is it. So if I type in a simple command like this, like tree, I should see a representation of my UI. So for example, you can see my title here is source. I have this UI label with source. You can see my subtitle here, and after that you can see the three buttons that I have. Now the most simple interaction I can make is a tab gesture. So I can say app.tab. This takes in an argument. So in order to know on which element to tap, I have to give it an identifier. So an identifier can be a label an element has, it can be a content description, it can be an accessibility identifier, and so on. Right now I have a button with the EUR text on it. I'm going to tap on that, and you will see that happen. The next one is the same. You can tap on British pound and it will take me to the next screen. And now it gets a bit complicated because this field is an entry field and I don't have anything specific about it, and I don't know how to identify it. So I can type a tree command again and maybe look at my UI. I already know it, so I can see here that I have only one field that is a UI text field. This is an entry field from iOS. So I can do something like this: app, query my UI, give me back a list of all the elements of class UI text field. If you have worked with LinkU, this should be familiar to you. Okay, now I have a list, and if I have many of them, I can do this. I can say app, show me this element, flash it. You can see it here. And now I want to put in some text. You can say app.enter text. I give it the element, and then I give it the text I want. You should see the keyboard, right? I can, I don't know, maybe tap on so I can do this, tap on the button, tap on the class UI button, but it's just easier and it helps cross-platform if you use labels. So I can tap on confirm. Oops. Yeah, typo. Confirm. Yes. And now I see the message. The way I can verify that it has appeared on screen, I can say like this: app dot wait for element I give it as well an identifier, and if it finds it within a reasonable period of time, it returns it. If not, it throws an error. What I can do now is copy my output, close, Control C.
So
Yes.
why do you set a reasonable amount of time? Can you tell, like, wait for us to the next second?
Yeah,
or is it
yeah,
more?
I can tell it how much. I think the default is like 1 second or so,
Thank you.
and I can specify. Yeah. Okay. This resolution is not going very great. So here I copied the output. I can even do it like this. I can comment a bit. So if you know arrange, act, assert, you can do it like this. Arrange, act, and assert. I can give my method here a prettier name. I don't know how much time I still have. Time? Okay, I'm just going to show you the finished project now. So I showed you some more libraries, and there's a particular one I like. It's called SpecFlow. I have it referenced here, so SpecFlow. And what it does, it translates Gherkin into .NET. So in short, I can write a feature in plain English, and my feature could sound like this. Sending local currency. The scenario I want to test is a successful transfer. And I have these 3 keywords: given, when, then, which I mentioned earlier. What SpecFlow does is matches this step to a step definition in C#. I'm going to do this. This is a similar test file. I have my 3 keywords: given, when, then, and then here I have a match of my step. And inside it, I can do the same interactions. The only thing different here is now that I take a screenshot of what's happening. And it's basically the same test I wrote earlier, but in a more like human format. I'm going to run it. Hope that it works. And I can take questions now if you have any.
So you're taking the screenshots just for confirmations?
Yeah,
or
for confirmation. Or what you can do is send these tests to a device form, and when it fails, if your test failed, you will have a screenshot of what happened, and you will know the exact step where.
So this is the one that's integrated with the Xamarin remote device testing thing.
Yeah. I don't know if I still have time, but if you still want
10
to...
minutes.
You have 10 minutes.
Oh, great. Okay, then I have more stuff to show you. Okay, I think this has passed. I can verify it. Yeah, so it has passed. I can show you the Xamarin Test Recorder. So if you don't want to write all these tests by hand, you don't want to use the repo, there's something much faster, but it has to load. Oh, here it is. Still very, very big. I think this is the best that we can get. So here, this is a standalone application. It watches how I interact with an app, and on the left-hand side, it outputs my C# test. Here, I select my simulator. I select the app I want to use, and it says now connecting to app. It will open a new instance of the simulator again, and it will will open the app.
And if you record a test using the iOS version, is that test going to be cross-platform and work on Android as well, or do you have to fine-tune it or something like that?
Usually yes, but if you use something very, very specific, like a UI text field, which is only available for iOS, you need to work a bit more to make it cross-platform.
Or have the tab bar at the bottom on iOS and at the top on Android, and all the other UI differences.
Yeah, but even that top bar or bottom, if it's common, you usually have the same elements on them, and you can say tap on an element with this label, and it can.
How does that work for internationalization, for instance? You had like find me the confirm button, so this would break the test of confirmación, whatever, confirmare.
Oh, yeah, this. Yeah,
So
but
you can search by identifier.
so if you localize your app, is this what you're asking? If you localize your app, so you could make your scenarios to look for a certain identifier. So let me show you if I can.
I think you can actually use locators instead of just plain text, like IDs or CSS identifiers or stuff like that, in order to be agnostic from the text itself, but still identify the element present regarding of the language. So if you go for ID, usually ID is similar no matter the language you pre-select for your app. So this would be safe to have an app translated in more languages. Use something that does not change, and then you can interact it no matter the language or no matter the platform, either iOS or Android. This is one way of doing it.
Yeah, and also in your BDD scenarios, you can pass in the words as arguments, and this might be a solution. So here on the left hand side, if I touch this button again, I should see. I'm not seeing. Oh, sorry. So I pressed the record button. Sorry. I tapped on something by accident. Now I can tap on another element. I can make basically the same things as before. And this one is correct, but for example, this one is not correct because I won't have a iOS render factory on Android, so I can say something custom about it. So I can identify it by, let's see, if it has an ID or text or something else. I think I tapped on the Euro text or something like this. Here you can enable the screenshot if you want it. And after I finish this test, I can copy the output as I did before from the REPL. I can export a C# file, which I can then embed in my project, or I can send it to Test Cloud. And this is the Xamarin device farm, so to say. They have a lot of devices, they're real devices. You send your app and your UI test to them, and depends on the size of your test, but in 10 to 20 to 30 minutes you should have the results back. And it's really great because they have a lot of devices which you don't normally have for testing.
Can you, among these tests, for instance, for item visibility, like this 10 elements need to be visible on the screen in case this is being tested on a device with a different form factor, things like that. Is that possible?
Yeah, so you can say wait for element, and if it finds it on screen, it will return it, then you know your test passed. If not, there will be an exception.
If it finds it on screen, or if it finds it visible, if it is
visible,
below or included, then it wouldn't find it.
Yeah. So you can pass in more options, but the default option is if it's visible on the screen, right now, not if it's present in the page.
Can I test arbitrary applications, or do they have to be built with Xamarin? So say if I have a legacy application written in Objective-C, can I test it as well?
You need to build the Xamarin test assemblies into it. So how this works is that, for example, the test recorder can connect to some library that I put inside this app, and it can make interactions with them. So you would have to maybe have the source code and package it with this library. It's called the Xamarin Test Cloud Agent. Yeah.
However, you did mention before that if you would have a JavaScript app, you put the body APK and put it in the project.
Yeah.
Does it work in case of Android applications?
So I think it works, but you need to somehow package in the test cloud agent inside the package, inside the APK.
So they're like a jar of the test cloud app.
Yeah.
So you cannot just take any app. APK, throw it in there.
No. Yeah.
Does this work for desktop applications as well?
For what?
For desktop applications?
No.
Like built for Mono, would the running of the tests or screen record this test recorder? Like does Mono have a solution?
No, it's just for Xamarin, and it works with iOS and Android, so it doesn't work with Windows Phone. What you could do for desktop applications is you could use SpecFlow, write your tests in given when then, and maybe use another library for UI interactions. Okay, anyone else? Alright, well, thank you, and enjoy your evening.